Hello guys, in this video I am going to tell you the solution of this question number 28 of chapter 8 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Derwin. So the question says that for the switch shown in this circuit, means this switch, this switch has been closed for 6 years prior to being flipped open at t equals to 0. So before changing this switch to open state, this switch was in closed state, means like this, for the last 6 years. It means that all the currents and the voltages across different element of the circuit, they must be constant, and current and voltages within the circuit, they must not be changing. They are not changing, right? So now with this conditions, it is given that we need to determine the IL, this, VL, this, and VR, this. So at t equals to 0 minus 0 plus 1 microsecond and 10 microsecond. So before starting with this question, so let me explain you what is this 0 minus and 0 plus. Now in with respect to the circuit, like we usually talk about three times. One is 0 minus, another is 0, and the third is 0 plus. Now the difference between these three is that if we look at this 0 minus time, 0 time, so this time is the time at which we have done any change. Like it is a time at which we have either switch open the we have opened the switch or we have closed the switch, right? So it is the time at which switch is open or closed, right? Now 0 minus, it is the time immediately before any change, before switch is opened or closed, means immediately before we did any change. So t0 minus is the time immediately before we have done any change with the switch. So immediately it means that it may be like 1 picoseconds or nanoseconds before this time. So very minute time before t equals to 0. And similarly 0 plus is the time immediately after the switch is opened or closed, right? So now with this three time, what we trying to see, like we are trying to find the condition of the circuit, that what is the condition at this time, what is the condition of the circuit at this time, and what is the condition of the circuit at this time. So now as the question is saying that we need to determine IL, VL, VR for t equals to 0 minus, it means we need to look for the condition of this circuit at t equals to 0 minus, which is the time immediately before the switch is opened. So immediately before the switch is opened, since it is mentioned that the switch was closed for the last 6 years, so it means this switch is closed, right? So I will redraw this circuit like this, plus minus. Over here we have a switch, right? This is a switch, it is closed because for the last 6 years it was closed. This is 1.2 volt, it is 1k, this is 1k, and now this is 2k, this is VR, this is VL, and this is IL. Now with respect to the inductor, we know that if the current and the voltages in the circuit are constant, especially for the inductor, if the current is not changing, if the current flowing through the inductor is not changing, then the voltage through the inductor, it will be 0. So over here, since the circuit is in this state 6 years, circuit is in this state for the last 6 years, and also the supply is a constant voltage. So because the supply is a constant and the circuit is in this state for the last 6 years, so it means that the current and the voltages in the circuits are not changing. And since current flowing through the inductor is also not changing, so it means the voltage across the inductor, it will be 0 volt. And since it is a 0 volt, so simply we can replace the inductor with the short circuit. So it is a normal, like normally we used to do this thing, that if the current and the voltages in the circuit are not changing, then simply we replace inductor with a short circuit, and similarly we replace capacitor with open circuit, right? So only if the current and the voltages are not changing. If the current through the inductor is not changing, then we replace it with a short circuit. If the voltage across the capacitor is not changing, then we replace it with the open circuit. So now for this particular circuit, this is the state at t equals to 0 minus, means immediately before the circuit was opened, circuit is opened, right? Now for this circuit we need to determine the IL and VR. VL already we know, right? VL already we know. So for this circuit now we can determine this IL and VR using any theorems. So let me use the nodal analysis. So using the nodal analysis, like I can take it as A node, this is a B node, and B can be taken as a reference. It means that VB voltage, it is 0 volt. Now applying the nodal analysis, simply I can write VA, like for this current, it is VA minus 1.2 upon 1K 1000 plus this current, it is VA upon 1, and then this current, it is VA upon 2 equal to 0. Right? And if you solve this, then at the end you will get VA as 1.2 upon 2.5, or simply 12 upon 25, or we can say it is 0.48 volt. Now if this node voltage is 0.48, then easily we can determine this IL. How? IL will be equals to VA upon resistance, which is 2K, 2000, right? 2000. So our VA, it is 0.48, 2000 equals to 0.24 milliampere. So our IL, it is 0.24 milliampere. Now the next is VR. Now to determine the VR, the current flowing through VR, it is IL, because it is the same branch, right? So the VR, it will be IL into 2, right? So it is 0.24 into 2000. So it is simply 0.48 volt VR. Right? We can, like for VR, like because we already know that the voltage of node A, the voltage at node B, it is 0. So simply VR can also be determined as VA minus VB. So in any way, either using this method or this method, we can determine the VR. So it means at t equals to 0 minus, at t equals to 0 minus, our VL, it is 0 volt, our IL, it is 0.24 milliampere, and our VL, it is VR, it is 0.48 volt, right? So it is at t equals to 0 minus. Now moving to the next part of the question, the next part of the question says what is IL, VL and VR at 0 plus. Now at 0 plus, to determine the values at 0 plus, let's draw the condition of the circuit at 0 plus. Now at 0 plus, this switch is opened. Since this switch is open, so this part of the circuit is not connected with this part, right? So this part of the circuit remains unconnected, and this voltage supply, because it is open over here, so this voltage supply will not be able to supply any current. But over here we have the inductor, right? Over here we have the inductor, and due to this inductor, because inductor has the power to store the energy, right? So its inductor has stored the energy using this formula, and since current was passing through this inductor, right, so it has stored the energy, and once the switch is opened, then inductor is going to use this energy to carry on the current. It will try to maintain the current using this energy, but of course, since this energy is limited and there is no external source, so inductor will try to maintain current, but ultimately current will become zero, because when when this energy is going to become zero, current will also get zero, right? So but overall, when the switch is open, when this switch is open, then our circuit, it will be simply, we have only this part of the circuit in the closed form. So now we have this is 1K, this is 2K, this is VL, right? And now this circuit, this is IL, right? Now over here, this and this, these are 3K, means they are in series, so we can find the equivalent resistance as 3K. Now if I compare this circuit with a general one, like we know that if the circuit is like this, R, L, and this is IT. So if the circuit is like this, then our IT, the current flowing through the circuit, it is given as this, right? Now if you compare this general circuit with this one, so over here the R, this 1K and 2K, they are in series, so our R, it will be 1 plus 2, 3K, or 3000 ohms. Our L, what is our L? Our L is this, right? What is the value of L? It is 30 millihenry, right? So our L, it is 30 millihenry. It means 30 into 10 power minus 3 Henry. Now substituting this value of R and L in this circuit, in this equation, we will get IT is equals to I naught e power minus R. R is 3000, L is 30 into 10 power minus 3. It is T. So it means we can rewrite this as I naught e power minus, so this and this are going to cancel, so it is 100, so it is 10 power 5 T, 10 power 5 T. So our IT is given as this. Now what is this I naught? We know that I naught is the initial current, means the current that is flowing through the inductor at t equals to 0 seconds. Now what will be the current flowing through t at 0 seconds? Now since we know for the inductor, we know that inductor will try to maintain the current. So at t equal to 0, when the switch is opened, then due to the property that inductor will try to maintain the current, so IL will not change. IL remains same at t equals to 0 also. So the whatever is the value at t equals to 0 minus, right? Whatever is the value at t equals to 0 minus, same value will be there for IL at t equals to 0 also. So already we have calculated that IL at t equals to 0 minus, IL is 0.24, right? So at t equals to 0 also, IL, it will be 0.24 milliampere. So it means this is our I naught. Our I naught is 0.24 milliamperes, right? So substituting this value in this equation that we obtain, so it will be IT equals to 2.4 milliampere, so 10 power minus 3 in e power minus 10 power 5 t. So this is our final equation, right? Now going back to the question is that at 0 plus we need to determine IL, VL and VR. So 0 plus is the time immediately after the switch is open. So we will, as we know that the current through the inductor, it remains same, it will not change immediately, right? So we will, whatever is the condition of the inductor at t equals to 0, it will remain as it is, right? So the current IL will remain same, it will be 2.4 into 10 power minus 3 at 0 plus, right? It will remain as it is, or simply 2.4 milliampere, right? Now for this circuit, the current, it is 2.4 milliampere, right? Now what will be our VL? Now before calculating the VL, if we calculate this VR, right, this is our VR. So what will be VR? Now through this, the same current IL is going to flow, right? Same current IL is going to flow. So over here the VR will be IL into 2. So IL is VR, it is equals to IL into 2002 kilo ohm. So it is 2.4 milliampere. So minus 3, this minus 3 milliampere, because it is milliampere, into 2000. So it is 4.8 volts, right? 4.8 volts. Now okay, just a minute, let me check one thing. Okay. It is 0.48. Okay. Something. I guess I did some mistake. Let me check again. 0.24. Yes, it is 0.24. It is not 2.4. It is 0.24. I have over here, I mentioned 2.4. Right? So it is 0.24. So it is not 0.24. It is 0.24, not 2.4. So 0.24. Similarly, over here 0.24, right? So 0.24. So answer, it will be 0.48 volt. So our VR at t equals to 0 plus VR is this, right? Now what about VL? Now if we look at VL, so the VL over here, the VL will be VL, like if I apply the KVL in this, so I need to start with this, right? So if the current is flowing in this way, plus over here, minus over here, so it will be 1K into IL, plus then current is over here and it is plus to minus, so plus VL, and then this is plus, this is minus, and we have already calculated it is VR, or simply 2K, right? So 2K plus 2K into IL equal to 0, right? So it means VL is equals to minus 3K into IL. So our VL, it will be minus 3K. Let me put this equation, this one, downwards. So VL is minus 3K into IL. So VL is equals to minus 3K into IL. Our IL is this. So minus 3000 into 0.24 into 10 power minus 3, right? So this and this are going to cancel, so we will get minus 0.72 volt. So our VL is this. So at t equals to 0 plus, our VR is 0.48 volt, our IL it is 0.24 milliampere, and VL is minus 0.72 volt. Now coming to the C part. Now the C part says that we need to determine the current at t equals to 1 microsecond. We need to determine these values at t equals to 1 microsecond, right? And then 10 microsecond. So it means in this equation, what I need to do? In this equation, I need to substitute t equals to 10 microsecond. So substituting t equals to 10 microsecond, what I will get? I will get IT is equals to 2.4 into 10 power minus 3 e power minus 10 into 10 microsecond. It is 10, right? It is 1. So first we need to determine for 1 microsecond. So means 1, right? So it is 1 into 10 power minus 6 second. So 1 into 10 power 6, right? So over here, this and this is going to cancel out. So we will get 2.4 into 10 power minus 3 e power minus 10, e power minus, sorry, it is minus 6. Over here it is 5, it is minus 6. So we're left with this, and this is minus 1. So it is 10 power minus 1, and 10 power minus 1 means, like 10 power minus 1, it is 0.1. So it is minus 0.1, right? So e power minus 0.1, we will get if you evaluate this, you will get the answer as 0.21716 milliamperes. So our IT at t equals to 1 microsecond, our IT, it is this. Now once we calculate IT, then using the same formula, this formula, we will calculate VR. VR will be equals to IL into 2000, right? So if you calculate this, so IL is 0.21716 into 10 power minus 3 into 2000. So we will get the answer as 0.43432 volt. So this is our VR. VR at t equals to 1 microsecond. And similarly for the VL, we have the formula, we got the formula like this, right? So it is minus 3k into IL. Our IL is minus 3k into IL is this one. So it is 0.22. Let me write 22 milliampere, right? So just putting it as 0.22 milliampere. So it will be minus 0.66 volt. This K and this milliampere will cancel out each other. So our VL is this, right? So at t equals to 1 microsecond, we get IL as this, VR as this, and VL as this, right? It is not IT, it is IL. Now the next part is that we need to determine at this t equals to 10 microsecond. So now similar, exact same thing we will follow, that at t equals to 10 microsecond, it means it is 10 into 10 power minus 6. So it is 10 power minus 5 seconds. Now IT formula is this, so we will substitute this. IT is equals to 2.4 into 10 power minus 3 e power minus, it is 10 power minus 10 power 5, right, into 10 power minus 5, right, 10 power minus 5. So over here this is and this is going to cancel out, so we will get 2.4 into 10 power minus 3 e power minus 1, right, and solving this we will get, now this is not IT, this is now becomes IL. So our IL, if you solve this, so our IL, it will be 0.088 milliamperes. Okay, now after this, then we need to determine VR again using this formula. So using this formula we will get like IL into 2000 or 2K, let me put 2K. So IL is 0.088 milliampere into 2K. Now this milliampere and K will cancel out, so 0.088 into 2, so we will get like 16, 1 carry 17, this 0.176 volt. So this is our VR. And then finally VL, again using the formula, VL is equals to minus 3K into IL. IL is 0.088 milliampere. This K and milliampere cancel out each other, so we will get 3 into 0.088, so it is 4, 24, 26, so this 0 minus 0.264 volt, so our VL is this, right? And now if you relate, so this is our answer for the IL, VL and VR at t equals to 10 microsecond. And again, if you look for the theoretical concept, we know that since in this circuit we do not have the source, right, in this circuit we do not have the source, so the current through the inductor, it is going to decay, it is going to die out. So starting from the initial current, the current that is flowing at t equals to 0, so starting from that, slowly exponentially it will decay out and it will become 0. And as the current is going to become 0, this VR and VL is also going to decay, and the same is reflected over here, like at 0 minus, this is the current, and you can see the IL, it is decaying, like it is decaying at 0 plus it is 0.24, right, at 1 it is 0.22, and at 10 it is this 0.88. So the current has decreased. Similarly the voltage, like at VR it is 0.48, at 0 plus it is 0.48, and then 0.43, and then 0.17. Similarly VL, like it starts from 0.7, then 0.6 at 1 microsecond, at 10 it is 0.2. So all the current, voltage and current and the voltage across the resistor and the inductor, they are decaying, and at the end if you calculate the current and the voltage at t equals to infinity, then you will get everything as 0. Means like if you in the same formula, in this formula if you put t equals to infinity, so at the end you will get IT equals to 0.24 into 10 power minus 3 e power infinity minus infinity. And since it is minus infinity, so it will become 0, so current will be 0. And since current is 0, so our voltages will also be 0. So it means our theoretical concept and the numerical values both will be same, right? And in this way we can also try to verify our answer if we are coming out with the correct answers or not. So with this I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.